Hello everyone. In this video, I'm going to cover the solutions to numbers 3 and 4 from our examples. Ideally, you've already worked them out on your own, and you're using this video to check to see if your method matches up with my method. As mentioned, there are multiple methods in solving this. I'm just going to go through my own personal method. Now, if you got stuck on something, that's fine. That's perfectly okay. Please watch this video for one way to solve out the trig identities, and please make sure to email me or ask during tutoring times so I can assist you in your own personal method. So we'll start with number 3. Sine x squared minus 1 over tangent x times the sine x minus the tangent x. I'm going to zoom in super far so I give myself plenty of space to work with. And we're going to start off with what's given to us. The sine squared of x minus 1 divided by my tangent of x times my sine of x minus a tangent of x. And that's just given to me. Now the first thing I'm going to do here is that I can see that in my denominator I have a tangent of x and a tangent of x on both sides of a mathematical operator, which means I can factor out a tangent x from my denominator. So I'm going to start with that. I still have my sine x squared minus 1 in my numerator, but now my denominator looks like tangent of x times the sine of x minus 1. And I got that just from factoring. Now I can't eliminate my sine x minus 1 and my sine squared x minus 1 because they're different operators. I know they look similar, but in my numerator I have my sine x squared. My denominator is just a sine x. But if we think back to algebra, there is a property, a rule about differences of perfect squares. Sine x squared being a perfect square, and 1 being a perfect square. The difference of squares states that I can rewrite this numerator in such a way that it will cancel out with my sine x minus 1. So I'm going to do that next. Such that my numerator is now going to be sine of x minus 1 times sine of x plus 1. And if you need a refresher on difference of squares, please look at the Algebra 2 video in the Algebra 2 previous courses folder. So difference of squares is what got me there. And I still have in the denominator my tangent of x times my sine of x minus 1. Now I can cancel out my sine x minus 1 with my sine x minus 1, and that'll give me sine of x plus 1 over tangent of x. And that's just simplifying. We're not done though. I want to do something like tangent x, because ideally I want to be able to put things in terms of sine and cosine, or get rid of fractions. Can't really do much about this fraction yet, but I can do something about that tangent. I can rewrite that tangent using a quotient identity to give me, let's see, different color. So I have my sine of x plus 1 in the numerator. My denominator is now going to be sine of x divided by cosine of x. That's just a quotient identity. Well, that's some fractional division right there. I'm going to shortcut that fractional division because I covered it in the previous videos. But essentially, by using my fractional division rules, I can rewrite this as the sine of x plus 1 times cosine x divided by the sine of x. If you need a refresher on that, please let me know. I'm happy to explain via tutoring or after class. So that's just my division rules. Furthermore, I'm going to take this sine of x in the denominator, and I'm going to turn that into my cosecant, because this sine of x in the denominator is technically 1 over sine of x, and that the 1 would be up there. This allows me to use my reciprocal identity to rewrite this as parentheses sine of x plus 1 times the cosine of x that we had before times the cosecant of x. And that's going to be a reciprocal identity. I'm now going to just distribute cosine x and cosecant x into my sine of x plus 1. See, different color. Yeah, we can start with purple again. No, red. We haven't done red yet. So I've got my cosine of x times my sine of x times my cosecant of x plus my cosine of x times my cosecant of x. And that's just distribution. Now there are a few things here of note. Recall that sine of x is equal to 1 over, no, sorry, let me rephrase that. Recall that our cosecant of x is equal to 1 over sine of x. That means this portion here is technically the sine of x divided by sine of x. So I can cancel out sine x times cosecant x as just 1. Meanwhile, my cosecant x times cosine of x, well, that's basically the same as cosine of x times 1 over sine of x. And cosine of x divided by sine of x is the quotient identity for a cotangent. So I can now rewrite my equation as simply the cosine of x plus the cotangent of x. And I got that from my quotient identity, comma, reciprocal identity, for my final answer of cosine x plus cotangent x. Number 4, we're going to start off with our cosine squared of x minus 1 divided by cosine squared of x minus cosine of x. And we're going to start off in a very similar fashion. Let's start with our given. We have the cosine squared of x minus 1. Hint, hint, that's a perfect square right there. As well as my cosine squared of x minus my cosine of x, both of which contain a cosine of x. This is given to us. I'm going to start by factoring out the denominator. So I'll have my cosine x squared minus 1. Divide that by my cosine of x, factored out by cosine of x minus 1. Factoring. I'm going to take a shot at my numerator, rewrite my cosine squared of x minus 1 as a difference of squares, such that I have cosine of x minus 1 times the cosine of x plus 1. And that's going to be over my cosine of x times my cosine of x minus 1. I can cancel out, therefore, my cosine of x minus 1 and my cosine of x minus 1. That's just simplification. So, difference of squares. And then simplification puts me at cosine of x plus 1 over cosine of x. I'm now going to expand that fraction into cosine of x over cosine of x plus 1 over cosine of x. Well, any number over itself is always going to be 1. Plus, well, 1 over cosine, that's a reciprocal identity for secant x. Oop, almost wrote something else. 1 plus secant x. That's what we get from simplification and a reciprocal identity. 1 plus secant x is the simplest form of this equation. Next slide. As you can see, answers to all of them. Of course, folks, if you have questions on these, please ask via email. I know that it can be a little tedious working through these problems, but there is an order to the logic. We'll touch base tomorrow.